Of all the objects in the cosmos,
Planets,
Stars.
galaxies.
none are as strange, mysterious, or powerful as black holes.
Black holes are the most mind-blowing things in the universe.
They could swallow a star completely intact.
Black holes have these powerful jets that just spew matter out.
First discovered on paper,
On the back of an envelope, some squiggles of the pen.
the bizarre solution to a seemingly unsolvable equation,
A mathematical enigma.
Einstein himself could not accept black holes as real.
People didn't even believe for many years that they existed.
Nature doesn't work that way.
Yet slowly, as scientists investigate black holes,
by observing the effect they have on their surroundings.
evidence begins to mount.
That is the proof of a black hole.
Millions of times the mass of the sun.
Cutting-edge discoveries show
We did it.
black holes are very real.
I thought it was crazy.
I said, holy.
But what exactly are they? If we could visit one, what might we see? With their immense power, do black holes somehow shape the very structure of the universe? Is it possible we might not exist without them?
It's quite a journey.
There are apocalyptic objects in the universe, engines of destruction, menacing and mysterious. Black holes. Even scientists who study them find them astonishing.
Black holes can sort of blow your mind.
I'm amazed that these objects actually exist.
Black holes defy our understanding of nature.
Black holes are the greatest mystery in the universe.
They're completely invisible, yet powerful beyond imagining. They can tear a star to shreds.
Black holes actually will eat anything that comes in their path.
You really want to avoid them at all costs.
Black holes even slow time. Once thought too strange to be real, black holes shatter our very understanding of physics. But we're learning they may somehow be necessary for the universe we know to exist.
They might well be the key players in the universe.
What are these strange, powerful objects? Outrageous and surprising. Where are they, and how do they control the universe? The search for black holes is on, and it will be a wild ride across the cosmos to places where everything you think you know is challenged, where space and time, even reality, are stranger than fiction. And we're starting that journey at a very unlikely place. Here, at a remote location in Washington State, where for the first time, a radical new experiment has detected black holes. It originated over 50 years ago, when a few visionary scientists imagined a technology that hasn't yet been invented. Searching for something no one is certain can be found. The experiment is daring and risky. Failure could mark their lives forever. But they don't fail. Right here in these facilities, they make a remarkable discovery. In the early hours of September 14th, 2015, they record a message. It looks and sounds like this. Just a little chirp. But that chirp is epic, monumental. The signal traveled over 1 billion light years to reach us. It started far, far away. And what it tells us is this. Somewhere in the cosmos, over 1 billion years ago, two massive black holes circle each other in a fatal encounter. Closer and closer they come, swirling faster and faster, until finally they slam together. The black holes create waves that spread outward, just like vibrations on a drum, a ringing in the fabric of space itself. The collision creates a massive blast, putting out 50 times as much power as the entire visible universe. It sends out a wave not of heat or light or sound, but of gravity.
This gravity wave is moving its way through the universe at the speed of light.
The wave races by stars. On the young Earth, supercontinents are forming. Microscopic organisms have just appeared.
Washing over one galaxy after another, after another.
Dinosaurs roam the Earth.
The wave is still moving.
It zooms through clouds of dust.
And then it nears the Milky Way galaxy.
The Ice Age is just beginning.
We're troglodytes, drawing in caves.
The wave reaches nearby stars. Albert Einstein is in the 6th grade. The wave approaches as close as Alpha Centauri. At midnight on September 13th, 2015, it is as close as Saturn. Finally, over 1 billion years after the black holes collide, the wave reaches us. It strikes a pair of revolutionary new observatories, the sites of the daring experiment. This is LIGO, the Laser Interferometer Gravitational Wave Observatory. The experiment, 50 years in the making, has finally hit the jackpot and opened an entirely new way of exploring the universe. For 400 years, almost everything we've observed in space has come to us in some form of electromagnetic energy. That little chirp is different. What hits the Earth in September 2015 is a gravitational wave, a squeezing and stretching of the very fabric of space. It produced no light. No telescope could ever see the collision. We needed an entirely new kind of observatory to detect it. That wave is new and direct evidence of one of the strangest mysteries in our universe, black holes. Most of us have heard of black holes. They're invisible, powerful,
We're talking about things that are 1 billion times the mass of the sun.
bizarre. A physical entity with infinite density. No beginning, no end.
They pull things in and warp light. Approach one, and time itself begins to change.
The gravity is so intense that a moving clock will tick slower.
Time will become so slow for you that you will watch the entire future of the universe unfold before your very eyes.
Fall in, and you'd be squeezed as thin as a noodle.
You'll be extruded through the fabric of space and time, like toothpaste through a tube.
Today, we know more about black holes than ever before. But the more we learn, the more mysterious they become.
They're the most exotic objects in the universe. We don't have the physics to describe them.
No matter how well you understand them, they remain unreachable in some sense.
Now, gravity's at maximum. Man is about to enter the black hole.
So black holes have a pretty fierce reputation. And if you want a villain for a sci-fi movie, cast a black hole. But in reality, what exactly is a black hole? And where do they come from? You might think a black hole is like this, an object, but it's not. It's a hole in the fabric of space, a place where there is nothing except gravity, gravity at its most intense and overwhelming.
So if black holes are all about gravity, gravity at its most extreme, what exactly is gravity?
We're all familiar with gravity.
Yep, it's Friday.
It rules our lives. But even so, for a very long time, how gravity actually works was one of the greatest mysteries. Over 300 years ago, Isaac Newton was fascinated with the behavior of moving objects. Eventually, he figured out his laws of motion. They work so well, we still use them today.
We have liftoff at 9:34 a.m.
But Newton's laws can only describe gravity's effects, not explain what it is. And here's where Albert Einstein comes in. Like Newton, he thinks about objects in motion. And he wonders what gravity actually is. Is it a force, or could it be something else? Here's what concerns Einstein. Take this apple. I can't move it without touching it. But if I drop the apple, it moves toward the earth. But what if I take my hand away, and the floor, and the basement, and the floor below that? Then what happens? The apple just keeps falling. Einstein realized that gravity had something to do with falling. Now, if I throw the apple, it falls along a curved path. But imagine I could get the apple moving much faster. Eventually, if I get the apple moving really, really fast, say 17,000 miles an hour, its curved path matches the curve of the Earth. The apple is in orbit, falling freely, just like the International Space Station and the astronauts inside it. According to Einstein, the apple and the space station and the astronauts are all falling freely along a curved path in space. And what makes that path curved? The mass of the Earth.
Einstein came up with a supremely simple concept, and that is that space and time is bent by the Earth and by the sun and by all the objects in the world.
So according to Einstein, the mass of every object causes the space around it to curve.
And that was Einstein's conception. There are no forces anymore. There's just objects bending space-time and other objects following the straightest line through it.
All objects in motion follow the curves in space. So how does the Earth move the apple without touching it? The Earth curves space, and the apple falls freely along those curves. That, according to Einstein's general theory of relativity, is gravity, curved space. And that understanding of gravity, that an object causes the space around it to curve, leads directly to black holes.